Hey everybody, welcome back. This is lesson 5.8, curve fitting with quadratic models. The objectives for today, you're going to be able to use quadratic functions to model data, and you'll be able to use quadratic models to analyze and predict. Your vocabulary for today is quadratic model and quadratic regression. Recall that you can use differences to analyze patterns in data. For a set of ordered parts with equally spaced x values, a quadratic function has constant non-zero second differences as shown below. So let's take a look at what we have here. In our x's, notice that we are going from -3 to -2 to -1, 0, 1, 2, 3. So each time we're equally adding +1. Every time we add +1. All right, all the way through. Now let's look at our y's. All right, and so in our y's we look and we're going from 9 to 4. In order to go from 9 to 4, we had to subtract 5. Okay, and then when we go to 4 to 1, we have to subtract 3. 1 to 0, we subtract -1 or subtract 1. 0 to 1, now we're adding 1. 1 to 4, we add 3. And 4 to 9, we add 5. So that is our first row of differences. Okay, that's our first. Now our second differences, let's see what our pattern is on the second row. So on the second row, we're going to go from -5 to -3, that's 2. -3 to -1, we added 2. -1 to +1, we added 2. 1 to 3, added 2. And 3 to 5, we added 2. So we had a constant second differences, all right? So this second layer is constant. And when we have that, we know that we have a quadratic function. Okay, so that's what's required in order to have a quadratic function. And a quadratic function is going to make a parabola when we graph it. All right. Let's look at an example. It says determine whether the data set could represent a quadratic function and explain why. So the first thing we want to do, again, is to find the first and second differences. Let's look at our x's first. Okay, when we look at our x's, we check to see if they're equally spaced. So when I look at that, I can see 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. And 7 plus 2 is 9. So I can see that my x's are equally spaced. So far, so good. Okay, next we're going to take a look at our y's. All right, so in our y's, I'm just going to go ahead and put it up here for us. -1 plus a +1, it took us 2. We had to add 2. All right, 1 plus 7, or 1 to 7, we had to add 6. 7 to 17, we add 10. And 17 to 31, we add 14. So we might not know for sure by looking at the 2, 6, 10, and 4 if we have a pattern there, but we have to go to our second layer. Okay, so what do we do to get from 2 to 6? Well, we add 4. What do we do to get from 6 to 10? We add 4. And 10 to 14, add 4. So there it is. Our second layer of differences are constant. So that tells us that this is a quadratic function because the second differences are constant for equally spaced x's. Okay, so our second was constant there. So that means that yes, we do have a quadratic function. Here's another example. Okay, again, we're going to determine whether the data set could represent a quadratic function. So first thing we want to do is find our first and second differences. Let's take a look at our x's first. Notice for our x's, we have 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 1 is 6, and 6 plus 1 is 7. So yes, we do have equally spaced x's. Now we're going to look at our first degree for our y's. 1 plus 2 is 3. 3 plus 6 is 9. 9 plus 18, 27. 27 plus 54 is 81. Okay, well that's our first degree, or our first set of differences, but we have to go down to the second set. So notice to get from 2 to 4 we add, 2 to 6 we add 4. 6 to 18 is adding 12, and 18 to 54 we had to add 36. So our second degree, or our second differences, are not constant for equally spaced x's, so we do not have a quadratic function. Try this one on your own real quick. Turn the video off and give it a try. Okay, hope that you were able to do that. So it says find the first and second differences. First of all, let's take a look at our x's and see if they are equally spaced. 3, 4, 5, 6, 7. Yes, they are equally spaced. So let's take a look at our first differences. 11 plus 10 is 21. 21 plus 14 is 35. 35 plus 18 is 53. 53 plus 22 is 75. So we don't even have to worry about our first differences. We are going to pay attention to our second differences. So 10 plus 4 is 14. 14 plus 4 is 18. And 18 plus 4 is 22. So we can see that our second differences are constant. So therefore, we have a quadratic function. All right, because we have equally spaced x values and the second differences are constant. Here's one more for you to try on your own. All right, again, we want to find the first and second differences, but first we need to take a look at our x's and see if they're equally spaced. 10, 9, 8, 7, 6. Yes, they are. Subtracting by 1, so let's look at our differences in our y. Okay, so here we see in our first, 6 plus 2 is 8. 8 plus 2 is 10. 10 plus 2 is 12. 12 plus 2 is 14. But this is our first, and we have to go to the second. When we go to the second, we have zeros here. So actually, although these zeros are all the same, it is not a quadratic function because the first differences are constant. So actually, in this particular problem, this is a function, is a linear function. So you're going to have, this is just going to be a straight line and not a function with a quadratic having a parabola as its graph. All right, just as 2 points define a linear function, 3 non-collinear points define a quadratic function. You can find 3 coefficients a, b, and c of f of x equals ax squared plus bx plus c by using a system of 3 equations, one for each point. The points do not need to have equally spaced x values. All right, so let's just remember about collinear points. They lie on the same plane. Non-collinear points do not all lie in the same plane. Let's try an example. It says to write a quadratic function that fits the points, and here they are. So let's take a look. Let's just remember what these coordinate pairs represent. The 1 is going to represent an x, and the -5 is a y. This is an x, this is a y, this is an x, and this is a y. All right, so we want to use each point to write a system of equations to find a, b, and c. Now notice that we have 3 variables. And when we have 3 variables, we need to have 3 equations also. So let's just make a little chart here and fill this in. The first point is going to be 1, -5. All right? And remember, this is our x and this is our y. And remember, f of x is the same as y. Okay, so I'm going to just put that on the other end here, equals y. So let's just fill it in. When x is 1, we're going to say a times 1 squared plus b times 1 plus c. Now we don't have a c anywhere, so we're just going to say plus c, and that is going to equal y, which is -5. -5, okay? So that's going to be a plus b plus c equals -5. All right, so there's one equation. We need another equation. Okay, so this time we have a point that's 3, 5. All right, so again, we are going to follow ax squared plus bx plus c. So we're going to say a times our x squared, and this time our x is 3, 3 squared plus b times 3 plus, again, we don't have c, so we'll just say c, and that is going to equal positive 5. So a times 3 squared is 9a plus 3b plus c equals positive 5. All right, our last point that we have is 416. 416. Okay, so we're going to again say a times 4 squared plus b times 4 plus c is equal to 16. All right, so 4 squared is 16, so we're going to say 16a plus 4b plus c equals 16. Okay, so now we are to find 3 different variables, and we have 3 equations. All right, so we're going to just do a little substitution and elimination and figure out what those 3 variables are. Okay, so now that we have our 3 equations, we can solve for our 3 variables. But let's remember what our goal is, all right? Our goal is to find a function, f of x equals ax squared plus bx plus c. All right, so I'm going to do some elimination and substitution, and I see that this a plus b plus c is a really easy equation. So I'm going to take my 9a plus 3b plus c equals 5, and I'm going to multiply this top one by -1, so that gives me -1a plus -1b plus -1c equals positive 5, because -1 times -1, 5 is positive 5. All right, I'm going to add those together. That leaves me with 8a plus 2b. 1c minus 1c is 0c equals 10. All right, on the other side, let's try this 16a. So let's go with 16a plus 4b plus c equals 16. And again, I'm going to multiply -1 by each of the points in this equation here. So that's going to leave me with -1a plus -1b plus -1c equals positive 5. All right, so now when I add these together, I get 15a plus 3b, 1c minus 1c is 0c, equals 21. Okay, so now I have 2 equations with 2 variables, and I want to solve, and I'm going to look at this, and so I think that the 2b and the 3b can get eliminated pretty easy. So I'm going to multiply my 8, or rather this first equation, by a negative, let's say a positive 3, and I'm going to multiply this equation by a -2. So 8 times 3 is 24a plus 3 times 2 is 6b equals 3 times 10 is 30. And over here, -2 times 15 is -30a plus -2 times 3 is a -6b equals -2 times 21, -42. Okay. So now we can add these together. 24 plus a -30 is a -6a. 6b minus 6b is 0, so we'll just put nothing there. And 30 plus a -42 is a -12. So we divide both sides by -6, and we have a equals 2. Okay, there's one of our variables. Now let's put it back into one of these 2 equations, and I think this equation looks a little easier. So I'm going to say 8 times a, which is 2. So I'm going to change that a to 2. 8 times 2 plus 2 times b equals 10. All right, so 16 plus 2b equals 10. Subtract 16 from both sides. That leaves me with negative 6 equals 2b. Divide both sides by 2. So I see that b equals negative 3. All right, so I've got my a and b, so now all I have to do is solve for my c. And I'm going to go back and use my very first equation because that's easier. So I'm going to say a is 2 plus b, which is negative 3, plus c is going to equal negative 5. So 2 plus negative 3 is negative 1 plus c equals negative 5. So I'm going to add 1 to both sides, plus 1. So I end up with c equals negative 4. So now all I have to do is go back to my original goal, which was to put it in this quadratic formula function equation. So I'm going to say f of x equals ax squared. And so I see that my a is 2, so I'm going to say 2x squared plus bx, and my b was negative 3, negative 3x plus c, which is negative 4. So here is my final answer. Okay. And of course, you can check this. You can substitute or create a table to verify that these points satisfy the function rule. And there, I've done it for you. You can see it on the calculator. Okay, here's one for you to try on your own. Turn the video on pause and give it a try. Okay, let's take a look at this one. It says write a quadratic function that fits these different points. So again, we want to use each point to write a system of equations to find a, b, and c in f of x equals ax squared plus bx plus c. Okay, so here's what we want to have. So let's remember, this is an x, this is a y. This is x, y, x, y. So we're going to start out with our first point, 0, comma, negative 3. Okay, so for every x in our quadratic equation, we're going to put in 0, and for every y, we're going to put in negative 3. So we're just going to remember that f of x is the same as y. So I'm just going to put our y on this side just so that it will all be in order. Okay, so now it says ax squared. So our x is 0, so we're going to say a times 0 squared plus b times x, which is 0, plus c equals y. And here we see that our y is negative 3. All right, let's do another one. Let's have 1 and 0. Okay, and remember, 1 is our x and y is our 0. So let's write our equation. A times 1 squared plus b times 1 plus c equals 0. And finally, we're going to use 2, 1, 2, 1. So it's going to be a 2 squared plus b times 2 plus c equals 1. Okay, so let's rewrite these equations out. So a times 0 is 0, and b times 0 is 0. So all we have left is c equals negative 3. Our next equation says 1a, so we'll just say a, plus b plus c equals 0. And our last equation, 2 squared, is 4, so it's going to be 4a plus 2b plus c equals 1. So now we have 3 equations, and we have to solve for 3 variables. So let's get going. All right, so now that we have our 3 equations, let's not forget what our goal is. Our goal is going to be to write a function f of x, so that's ax squared plus bx plus c. So that's what our goal is. And I'm going to solve. I'm going to start out, and this is lucky that we can just go ahead and substitute our c into our 2 equations here. So I'm going to say a plus b plus negative 3 equals 0. So a plus b equals 3. Just added 3 to both sides there. And our other one says 4a plus 2b plus negative 3 equals 1. add a positive 3 to both sides, and I end up with 4a plus 2b equals 4. All right, so now that I have that, I have two equations with two variables in it, a plus b equals c, and 4a plus 2b equals 4. So how about if I multiply this equation by negative 2? So negative 2 times a is negative 2a plus negative 2b equals negative 6. All right, so when we add that together, 4 minus 2 is 2a. 2 minus 2 is 0, and this is going to equal negative 2. Divide both sides by 2, and we end up with a equals negative 1. Well, that's handy now. So now I know that a equals negative 1, and I also know that c equals negative 3. So let's just put it into our original easiest equation and say negative 1 plus b, which we don't know, plus c, which is negative 3, is going to equal 0. All right, so negative 1 plus negative 3 is negative 4 plus b equals 0. So let's add 4 to both sides plus 4. So we end up with b equals 4. So now I have three variables, and I need to just go back and rewrite it into my quadratic function. So I'm going to say f of x equals a, which is negative 1 x squared, plus b, which is 4x, plus c, which is negative 3. And so here is my final answer. And again, there's a variety of ways that you could check. You could substitute or create a table to verify that these points do satisfy the function rule. The good news is you may use any method that you studied in chapters 3 or 4 to solve systems of 3 equations in 3 variables. For example, you can use a matrix equation as shown, or what I would do is I would use the RREF function that you learned. It's on your calculator, and that makes your life much easier. So if you don't remember how to use the RREF, row reduced echelon form, you might want to go back and relearn that, because that'll save you lots and lots of time. Okay, a quadratic model is a quadratic function that represents a real data set. Models are useful for making estimates. In Chapter 2, you used a graphing calculator to perform a linear regression and make predictions. You can apply a similar statistical method to make a quadratic model for a given data set using quadratic regression. So here's a helpful hint. The coefficient of determination, r squared, shows how well a quadratic function model fits the data. The closer r squared is to 1, the better the fit. In a model with r squared equals 0.996, which is very close to 1, the quadratic model fit is a good fit. Take a look at this example. It says the table shows the cost of circular plastic wading pools based on the pool's diameter. Find a quadratic model for the cost of the pool given its diameter. Use the model to estimate the cost of the pool with a diameter of 8 feet. Okay, so I'm going to go ahead and pull up my calculator, and we're going to do this on the calculator here. So the first thing we want to do is go ahead and we're going to figure out how we can put this information into our calculator. Well, what we're going to do is we're going to go to Stat, and we're going to Edit, which it's on right now, Enter. And we're going to put them in List 1 and List 2. Now, how do I know what List 1 and List 2 is going to be? Well, I want my List 1 to be my X value and L2 to be my Y value. So let's think about what X and Y are going to be. Remember, X is always our independent value and Y is dependent on X. So whatever X is, so in this case, our cost is dependent on how big the diameter of our pool is. So if we want a 5-foot pool, then our cost is going to be this amount. So depending on how big your pool is, that's what your cost is going to be. So that tells us that the diameter is going to be our independent variable, our x, and the cost is going to be the y. It's going to be dependent on the x. So what we're going to put in L1 is our x's, our independent variables. So here, once we're in L1, we're going to just put in, we can do this pretty easy, 4, enter, 5, enter, 6, enter, and 7. Okay, so now that I've entered my x's, next I would need to enter my y's, and I've already done that for us just to go a little bit faster. So the next thing I want to do is come to this button, Stat. Okay, it's right here, Stat. And this time I want to go to Calc, and I'm going to come down to Quad Reg. All right, and once I go there, I'll notice it says I want my x to be from list, and I told it list 1. But I have in here list 3, so I need to change that. So I'm going to clear that out. I'm going to say second list. I'm going to choose list 1, enter, and there it is. Okay, now list, my y value is coming from list L4, but I don't want it L4, I want it in L2. So again, I'm going to go back to my list, go down to L2 and enter. So now my x value is in my L1, my y value is in L2. One more thing that I want to go to is this store. And I want to go ahead and store this. I'm going to go to this button here that says vars, it's variables. Okay, and I'm going to choose the y vars, okay, and I'm going to put it in a function because I want this to be a function. It's a quadratic function, and I'm going to choose it to be y1, enter. All right, so once I've done that, now I can just come down here and I can enter calculate, and I'm going to push calculate, and here it put it into my quadratic equation, ax squared plus bx plus c. It tells me what my a is, what my b is, and what my c is. And remember, this R2 is going to tell us how close of a fit is, and ours is 0.999, which is super close to 1. So this is a really good fit, very close fit. Okay, so some things that we can do with this, once I've seen this, I can actually see that I put it into y1. And now that it's in y1, so you can kind of see it's 2.41 x squared plus a negative 20, let's see if I can get to it, plus a negative 21.562, blah, 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 x plus 67 point something. Okay, well, I can actually take a look at my question said, use the model to estimate the cost of a pool with a diameter of 8 feet. Well, now that I have a nice quadratic equation for it, I can figure that out. But I can also just come up here to second table. Okay, so I click second, and I see the little arrow. And so now I'm going to click table. And so now I see if I want a pool with a diameter of 4 feet, it's going to cost me $19.90. This says 98, so that's pretty close, not exactly, but that's okay. And then my if I have a 5 foot in diameter, it's going to cost me approximately $20, and this says 13, but again, this is just a getting it as close as possible. All right, and so if I want a pool that's 8 feet in diameter, which was the answer to my question, I can see here that it's going to cost me $49.53. Okay, so just to summarize that, says the quadratic model is this, and we can go back and take a look at that real quick, just so you can see it one more time. Okay, here we go. So it says my A is 2.41, 2.4, negative 21.6, and 67. There's my quadratic model. And if I want to buy my pool, it's going to cost me $49.54, which we saw just a little while ago when we did our second table. Went to $8, $49.54. So there you've got it. All right, I'd like you to try one on your own. I want you to think about it for just a minute about where the X's and Y's are going to go, and then I'll help you with it. So turn your video off for a minute and give it a try. Okay, so this problem says the table shows approximate run times for 16 millimeter films given the diameter of the film on the reel. Okay, so that tells us that our independent variable is going to be the diameter, because we can have different diameters, and that's going to give us the approximate run time. So we're going to have to find a quadratic model for the reel length. So we're looking for the reel length, so that's going to be our y, given the diameter, that's our x of the film. So use the model to estimate the reel length for an 8-inch diameter film. So we're going to look for an 8-inch. Now this is like a best fit. This is not going to be exact, but it's going to be an best fit. So that's what we're looking for. Okay, so first thing we need to do is input our list. So we're going to go to Stat. We're going to go to Edit, which I'm at, and I'm going to click Enter. And now I'm going to go ahead and go to L3. I'm going to put my X's in L3, and I've already done that, and I hope you have too. And then I'm going to go over to L4 and list my Y's, the ones that I want Y's, 200, 400, 600, and there they are right there. Okay, so now all I have to do, I need to do my model, quadratic model. So I'm going to go to Stat again. This time I'm going to go to Calc. I'm going to come down here to the Quad Reg, click Enter. This time my X's are no longer in L1. Now they are in L3. So I'm going to clear out L1. Go to second list, choose L3, enter. Now I'm going to come down. My Y's are no longer in L2. My Y's are now in L4. So again, click that, go to 4, enter. Once again, I want to save everything in Y. So I'm going to click vars and go to Y, enter. The function is where I want it. Y1 is where I want it, and now I go to calculate, enter, and there it is. Now I can see what my A is going to be. It's going to be 14. My B is going to be negative 112, and my C is going to be 430. My R2, R squared here, is going to tell me how close of a fit I am, and it's a pretty close fit too. 0.996 is very close to 1, so I'm going to have a very close fit. Okay, so my question said to write my quadratic model, so I can write that out, and then it says use the model to estimate what it would be for an 8-inch diameter film. All right, well, we can just use our table. Let's go second table, and here it's going to tell me that 8-inch is going to be 446 is the real length if I have an 8-inch. So that is our answer. And so just to summarize this one more time, here is what our model would be, and we can see again, just taking a look at it one more time to prove that up. All right, let's go down here to calculate, enter. And we can see A is 14.3, and here it is, 14.3, negative 112, and then positive 430 for our C value. All right, and again, when we click table, we can see that for for a diameter of 8 inches, the model estimates the real length to be about 446 feet. So there you have it. I hope that you learned something and found that very helpful. That's the end of our video, and I will see you in class. Have a good day. Bye.